p percentile of the distribution is the value with p% of the observations below it. The first quartile is the 25th percentile. It is the median of the first half of the observations. The third quartile is the 75th percentile. It is the median of the second half of the observations. Quartiles can be used to measure position and draw box plots, which display the 5-number summary. Converting observations from their original values to standard deviation units is known as standardizing. The formula for standardizing an observation is z equals x minus mean over standard deviation, where x is the observation.
In doing an FRQ, it is common to forget to include the z-score formula, but make sure you do or else you will lose points. Here's how to find the 5-number summary on your calculator. So we already have our data entered in the lists in list 1. Now you go to stats and then calc and one variable stats. Then it's in list 1. We do not need anything for the frequency list, and then we calculate. Now this will give us our 5-number summary down here. We have our minimum, our quartile 1, our median, our quartile 3, and our maximum.
Measuring center, mean and median. When measuring center refers to the peak of a unimodal distribution. So the mean is the sum of the observations divided by the number of observations, which is n. In formula, that is x bar is equal to the sum of xi divided by n. The mean is not resistant, meaning that extreme outliers will change the mean. In a density curve, the mean is the balance point and the median is the equal areas point. The median is the 50th percentile of the distribution, so half of the observations are above and half are below it. The median is a resistant measure of center, so it is not affected by extreme outliers. To find the median, first arrange the observations in order from least to greatest, and the median will be the middle observation if there is an odd number of observation, whereas if n is even, the median will be the average of the middle 2 observations.
If the mean is greater than the median, the distribution is skewed to the right, and if the mean is less than the median, the distribution is skewed to the left. If they are about the same, the distribution is symmetrical and approximately normal.
Now for measures of spread, which include range, interquartile range, standard deviation, and variance. One measure of spread that we should already be comfortable with is range, which is the largest number in the dataset minus the smallest number of the dataset, as we can see from this equation here. As we stated before, the quartiles are good measures of position. They can also be used to help find the measure of the spread of a distribution. For example, the first quartile and the third quartile can be used to find a measure called the interquartile range. This value can be found with the following formula. IQR equals Q3 minus Q1. Lastly, the values of standard deviation and variance can be used to measure spread as well. The standard deviation measures the average distance that the data points usually are from the mean of the data set. It is calculated by finding the average of the squared deviations and then taking the square root. This value squared is the variance. The equations are here, but for the most part they will give you these values since the equations are so complicated. Now for the interpretation of standard deviation. We have already stated this, but the standard deviation measures the average distance that the data points usually are from the mean of the data set. Then for interpreting z-scores, the units of z is standard deviations away from the mean. Positive z-scores are above the mean and negative z-scores are below it. In order to find the percentile of a certain observation, you can either use A, normal CDF on the calculator, B, the standard normal table on the formula sheet, or C, the 68, 95, 99.7 rule. As we can see from this normal distribution here, we have 68% of the data within 1 standard deviation, 95% within 2 standard deviations, and 99.7% within 3 standard deviations of the mean. Just to refresh on how to get to normal CDF on your calculator, you're going to go second, vars, which gets you to distribution, and then here it is, number 2. And then you will integrate your lower, upper, and then keep your mean at 0 and your standard deviation at 1.
Okay, so for linear transformations, when you add or subtract a constant, it'll add or subtract that number for measures of center and location, like mean, median, or quartiles, but it doesn't change the shape or the spread, like range, IQR, and standard deviation. When you're multiplying or dividing a constant, it'll multiply or divide that measure of center, location, and spread, like mean, median, quartiles, range, IQR, and standard deviation, but it still won't change the shape.